This is N&I Bites, Big Learnings, a podcast where fellow healthcare professionals converse about the latest in nutrition science. We are joined by the chairs and speakers of N&I and WNSC Workshop 103 as they share practical insights on early life nutrition and its impact on children's long-term well-being.
Hello and welcome to Nestlé Nutrition Institute's podcast series, N&I Bites, Big Learnings. I'm Ronan Shamir, your host for today, and I'm thrilled to welcome Dr. Sean Deoni, Associate Professor of Pediatrics and Radiology at Brown University's Warren Alpert Medical School and Director of the Advanced Baby Imaging Lab. Dr. Deoni's research focuses on understanding how early life environments, including nutrition, shape brain structure and cognitive development from infancy through adolescence.
Perfect. Yeah, great. Thank you so much. Thanks for having me. I'm excited to be here.
Good. So let's start by asking you, Dr. Deoni, your work focuses on brain and cognitive development spanning from infancy through adolescence. Let's start at the beginning. How does the brain develop in early life, and why is this period so nutritionally sensitive?
That's a great question. I think we could actually probably have about 12 series of this podcast just talking about early brain development. But in essence, if we take sort of a global picture, the brain develops very rapidly over in particular, the first 2 years of life. And that's everything from the initial formation, of the early brain structures and early brain networks that happens during fetal development. And then as the child is born, that early postnatal development is really just a number of changes, both structurally, so macro and micro architecture of the brain's white and gray matter. We have functional changes of the functional architecture as the brain's networks get laid down. We have metabolic changes, cerebellar changes in cerebral perfusion, etc. The things that we really focus in on our lab is looking at the structural changes, looking at how the brain structurally matures. And so we know, for example, that the brain grows and expands by about a factor of 3 over those first 2 years of life, reaching about 80% of the adult value, or adult size. And that's driven, as I say, by changes in the underlying white and gray matter. Gray matter changes through neuronal genesis and synaptogenesis, so the number of connections and the number of neurons in the brain. And the white matter, which is really the connections of the brain, matures via a process called myelination, which is literally laying down a lipid layer around those neuronal axons that connect up different parts of the brain and really acts as a speed limit, as it were, allowing information to flow more rapidly. And the more myelin you have, the faster information can flow across your brain. And of course, the faster information can flow across your brain, the more interesting things you can do cognitively. You can begin to process information across different systems, etc. So even something as simple, perhaps, as catching a baseball, requires information to go obviously from your visual system to your motor system to your planning system, and then finally down to your spinal cord. And so the faster you can send information, the faster you can catch a ball. So that's all happening. And of course, to allow that to happen, to get to the second part of the question of why it's nutritional, why there's a dependence on nutrition, you really require 2 things to drive brain development. The first one is stimulation. Stimulation drives that maturation. It's much like building a muscle. So when you're doing weights or whatnot, you're building muscle. It's the same as the brain. As you do stuff, you develop those brain systems. But in order to develop it, you need to have the structural components to build. And that's where nutrition comes in. So having the right nutritional building blocks that are part of the brain system, part of the brain myelination, part of the brain myelin content, or are involved as energy sources, so the synthesis of myelination, or all the various other things that happen to help adhere that myelin sheath to the neuronal axons. So you need that stimulation and you need that fundamental nutritional building blocks to actually make that all happen, and they all have to come together at the same time. So it's a pretty amazing process that it actually all works.
Very, very much, and it's really amazing. So you explained to us how myelination helps this rapid transport of information, but could you elaborate a little bit on how nutrition supports it, and also are the brain's dynamic nutritional needs, is it changing over time?
Yeah, very much so. So nutrition plays such a critical and important role in all this because in order to build a myelin sheath, you need to have the composite pieces of that. And that's predominantly, it's a phospholipid bilayer. So you need to have the fatty acids and other components, phospholipids, that are there that get put together to actually wrap around that myelin sheath by the oligodendrocytes. That, of course, is happening. We talk about myelination of the brain happening very rapidly over the first 2 years of life, but it's happening in a very carefully choreographed way. So it's not just the whole brain myelinating simultaneously, but it's actually myelinating in different brain regions. So the first areas that begin to myelinate are the central brain regions. So areas that are particularly involved in motor development. So grabbing and holding things, because the first thing a baby does is grab stuff and put it in their mouth. Then the next things that begin to develop is it begins to shift backwards to your visual areas, because now the baby looks at stuff that they're putting into their mouth. And then it begins to move outwards to the sides of the brain where you have some of your language areas. And so, the baby is cooing and cawing, and those systems begin to develop. And then finally, over the first, tail end of the first year, you begin to move forward into the more recent parts of the brain, or more recently evolved parts of the brain in the frontal cortex, which is where your planning, your social emotional systems are. And so that's when you start to cry when your parents take the ball away from you that you wanted to put in your mouth. So across each of those time periods, you're having different nutritional needs that are coming in to support the structure and the establishment of that myelin sheath as things are developing. So all that's happening. And then, of course, once you have that very rapid development, which sort of peters out at about 2.5 years of age, then other processes begin to come in, and they require a different set of nutrients to help support those. So you go from this very rapid dynamic phase of development to then supporting and maintenance and continued maintenance of that sheath. And so your nutritional needs are bouncing all over the place. So yeah, it's very much a dynamic process that's happening both temporally, but then also spatially throughout the brain.
Thanks. Well, that's an excellent answer to a very complicated question. Moving to your resonance study, it follows children longitudinally over time. What have you learned about how nutritional needs evolve as the brain matures beyond what you just explained, and how the myelination affected by DHA and colic intake?
Yeah, very much. Certainly, during fetal development, the brain, towards the tail end of fetal development, you have early myelination within the brainstem, and that's predominantly supported, obviously, by mom's nutrition and the nutrition coming from the placenta. Then, obviously, you have early postnatal myelination, as we say, over the first 6 months to 12 months, where we have hopefully exclusive breastfeeding for at least the first 6 months, and so that nutrition perfectly supports neurodevelopment. And again, because it is a phospholipid bilayer, you need a lot of fatty acids. So that's everything from your long-chain polyunsaturated fatty acids that we hear so much about, things like DHA, right? We hear a lot about DHA being important for brain development. But in that pathway to build a myelin sheath, you're really taking those fatty acids, you convert those into ceramides. Ceramides, which is another class of fat or lipids, get converted into sphingolipids and sphingomyelin, and then that ultimately becomes part of the myelin sheath. So you have these very, very characteristic patterns and well-described mechanisms of and chemical pathways that ultimately lead to your myelin sheath. So things that are needed, therefore, are those fatty acids. They're the building blocks that start. And then you have all the other components that go into that. Sphingomyelin is really a fatty acid with a choline chain attached to it, or a choline head. So that's why choline comes in. So you need
So you also need choline.
Yeah, exactly. So all these things come together. And so you can dump a whole bunch of DHA into a child's diet and not do much. But if you have the choline, then you start to build that together, or you can put in the sphingomyelin at the top. And so, yeah, all these things begin to come together.
What about cholesterol?
Cholesterol, same thing. So again, another lipid source that's incredibly important for within that myelin sheath. So really, the myelin sheath is composed of sphingolipids, phospholipids, gangliosides, and cholesterol. So you need all those to have a fully functioning myelin sheath. So the more of all of that, and again, these are all things that we tend to avoid in our diet as we get older, right? Because we tend to avoid fats. The idea of, at least in the US, the moment on the lips, forever on the hips mindset, we try to avoid it, but it's still incredibly important. We need it for our brain. So the more that we can get into our diet, the better.
Yeah, well, I think we're also shifting from this low-fat diets.
Right.
But
Yep.
very interesting. Also, in your lecture, you talked about niacin, which was very surprising to many of us.
Yeah.
Could you elaborate a little bit on how you came across niacin and its importance?
Yeah, that was an interesting one as well. There's a few things. So as we began to look not just at the first 1,000 days, but actually tracking children throughout childhood and really looking at temporal relationships with different nutritional intake and what was really supporting myelination as that child grew older and then ultimately went into school. We saw that there's that early phase where obviously you need a lot of lipids and a lot of other key nutrients. That need was maintained, but then other nutrients became important, vitamins, etc. And then we began to see other classes of lipids, and then certainly niacin began to pop up, which was something that was surprising to me. In fact, when it was just one of those things that came out of the analysis, and we sort of had to go back and go, well, why would we see that? But actually, then going back and understanding what it's doing, it actually makes a lot of sense. Certainly, we see niacin and its predecessor, so nicotinamide, being incredibly important as a nutrient. So it's incredibly important across the brain. It helps with synaptogenesis. It helps with synaptic transmission. So the actual, and of course, synaptic transmission and activity in the neuron is what drives myelination. It's also actually involved in myelin synthesis. So it plays a role on both sides of the fence, right? It helps, drive brain function and activity, which drives myelination, and then it's involved in the myelin sheath itself. So, kind of surprising initially that it came out, and then it actually made sense that it came out in the analysis. Kind of gave us some hope that actually what we were looking at made sense. It had biological relevance.
Does make sense, certainly. We're approaching towards the end of our podcast. I'd like to ask you, everybody now talks about personalized nutrition. Do you see a place or a potential for translating your work into tailored nutrition for the growing children with different needs?
I think so. I think there's certainly a number of companies that have started to attempt that with breast milk analysis. So you can, you see them in newspaper or TikTok and other ads or whatnot, where you can actually send off samples of your breast milk. They'll analyze it and send you back and say you should eat more of this while you're lactating. I'm not sure I necessarily agree with that, and I don't think we're at the personal level yet. But I certainly think, as we look across cultures, we look across different areas, we can certainly see how we can, certainly inform, for example, the formula market, right? What needs to be in their formulas that changes as that children grows. How can we improve that so we get closer? I don't think we'll ever obviously mimic breast milk, but can we get closer to that? And then, of course, as we move off of breast milk, are there ways that we can ensure that certain nutrients are provided that have been overlooked, right, or just not really understood? And can we now begin to create or help emphasize that in a child's diet and sort of make sure that children are receiving that full complement of the diet that's necessary, not just to support physical growth, but also neurodevelopment and cognitive abilities. So, yeah, I don't necessarily, I'll never say never. There's obviously a time potentially where we get to a point where people could do individualized nutrition, much like athletes do today. That's certainly a possibility, but I certainly can see it in the horizon on a population level for sure.
Thanks. So really, thank you for your amazing insights. Before we end, what's the one message you'd like to leave with our listeners?
I think the biggest surprise that we found is just what the extent of the extent of how much nutrition plays a role in child development. It tends to get sort of overlooked. A lot of people will say, oh, children are resilient, they get what they need, etc. But actually, it's something that's incredibly important. But even more than that, it's modifiable. It's something that we can easily change. You look at all the other factors that we find being important for child development, child cognitive development. Certainly it's the home environment, it's learning opportunities, etc., reading to your child. But if you pair those things, reading to your child, stimulating with them, playing with them, tickling them, talking to them, with optimal nutrition or the best nutrition you can provide, you really get a huge bang for your buck. Like, it's a big, big change that you can instill in those kiddos and give them a really good chance at becoming the ultimate themselves that they're going to be. So, it's not something to be overlooked. It's so easy that it's easy to overlook it, and yet it's incredibly important.
Well, I hope that our listeners are as enthusiastic as you are. I'd like to thank you again, Dr. Deoni, for joining us on NNI Bytes Big Learnings. And thank you to our listeners for tuning in. Stay with us for more episodes exploring how science, nutrition, and innovation come together to nurture a healthier, brighter future starting from early life.
Perfect. Thank you so much. Thanks for having me.
And that concludes today's episode. Thank you for joining us for this special episode from NNI and NSC Workshop 103. We hope you enjoyed and learned from this quick discussion, fellow experts. Till the next episode.